Hello everyone and welcome to VR Learners. I hope my screen is visible. So this is something that I get in my inbox. Sir, we wanted to have few questions on factor theorem, right? That means how we can have some questions performed with the help of factor theorem. So I'm taking two examples, right? These are very popular. I usually, get these questions in my DM. So I've taken the same, right? I'll try to explain what do we understand by factor theorem and why we are using, factor theorem in order to simplify this. Why don't we have any other mechanism? And if there is any other mechanism, then how we can have the same approach. So let us have a look here. I hope my screen is visible. Yeah, so the very first question is x cube minus 6x square plus 11x minus 6. We need to factorize this using factor theorem. All right, breaking it into factors. But before than that, I just wanted to have an understanding whether you people are comfortable enough with factors or not. Let us consider an example. Suppose 6 is a number. So what do we understand by factors? If I'll ask you, is 6 divisible by 1? So if you divide 6 by 1, you'll get what? 6, right? That means 1 is a factor. Complete division I'm talking about. If I'll divide 6 by 2, yes, this division is possible. I'll be getting 3, right? Without any remainder. Is 6 divisible by 3? Yes, 6 is divisible by 3. I am getting, a number free from any remainder. 6, is it divisible by 4? No. Is it divisible by 5? No. Is it divisible by 6? Yes, 6 by 6 is 1. All right. So that means these are the factors. These are the numbers that divides the number that we have taken into our consideration completely. One more fact that I wanted to highlight here, why I have chosen 6 as the number. See, if you add the factors, right, other than the number itself, you'll get 6. So if you are getting something like this, right, then this particular number is known as a perfect number. So this is one such topic that we have, taken, although we are having a different topic in our context, but yes, perfect number is something that I want you to introduce with. All right. So 6 is a perfect number. Let's get back to our discussion. Yes. So I hope I have answered what exactly do we understand by factors. Now, how to factorize something and what do we understand by this? Let us take a numerical example. Suppose if somebody is asking me to divide 17 by 2. Although it is written like this, I have expressed it in this form, right? We know that 2 into 8 is 16. If we subtract, remainder is 1. Can I write 17 in this form? 8 into 2 plus 1. Dividend equals divisor into quotient plus remainder. Right. This is the quotient, divisor, and remainder. Okay. So that means we can express it like this. Dividend equals divisor. Although here divisor is 2 into quotient plus remainder. So here we have a remainder, right? But what if I am taking a different example now? What if someone is asking us to divide 18 by 2? Then 2 9s are 18. All right, remainder is 0. So if I'll express it using dividend equals divisor into quotient, so dividend is 18, divisor is what? 2 into quotient plus remainder is 0. That means I can say practically that this 2 and 9, these are the factors of 18. I can say it like this, right, people? Because I know that 18 is divisible by 2 and 18 is also divisible by 9. So these are the factors. This is the same concept that we'll be using in factor theorem. All right. We express P of x as Q of x into D of x plus R of x. So if this comes out to be 0, then we say that these are the factors. This is actually, a polynomial in x. Right? This is just the representation that I am representing. Instead of calling this as P of x, you can also call this as f of x or function of x. All right. Or sometimes you can call it with any other letter of your choice. Fine, people. So we'll try to elaborate more on this now. Let us consider very first question. We need to factorize it, right? That means according to factor theorem is when the remainder is 0, right? That means we can express a polynomial in this form. If the remainder comes out to be 0, then we can express a polynomial in this form. That is what factor theorem states. Fine. So now suppose if somebody is asking us to factorize x cube minus 6x square plus 11x minus 6. X cube minus 6x square plus 11x minus 6. Let us see if we have copied the question correctly or not. Yes, we have copied it correctly. All right, so this question will be answering here. Now we need to find one number, right, which when substituted in this will give us 0 of polynomial. What do we understand by 0 of polynomial? Let this be p of x. All right, I have expressed this in this format. Now I need to calculate the value of x for which this particular expression becomes 0. That is nothing but 0 of a polynomial, right? So let us use hit and trial method. Let us substitute x as 1. All right, let us try whether x, when we substitute x as 1, we'll be getting this RHS as 0 or not. So let us try substituting it here. It will be 1 cube minus 6 into 1 square plus 11 into 1 minus 6. So this comes out to be, so I'm calculating it for p of 1. So this comes out to be 1 minus 6 plus 11 minus 6. So this is 12 minus 12. When you subtract, it will be 0. So yes, when I substitute x as 1, I am getting p of x as 0. That means p of 1 as 0. What do we understand by this? This is actually, an enhancement of remainder theorem as well. When somebody is asking you to calculate the remainder directly when some function is divided by some other function, right? So instead of going through long division method, you can directly calculate what exactly the remainder of something comes out to be. Fine. So here the remainder is 0. That means we are eligible to have this question with the help of factor theorem now. All right. So if on substituting x as 1, we are getting 0 of this polynomial. That means we can say that x minus 1 is, according to this, if you shift the 1 to the other side, you'll get x minus 1. It is a factor of p of x. Is a factor of p of x. And what is p of x? X cube minus 6x square plus 11x minus 6. Fine. Now you need to see this very carefully. I hope I have copied the question correctly. Yeah, I have copied it correctly. Right. Now you need to see the degree of this polynomial. The degree of this polynomial is what? 3. All right. You can call this as g of x and this as p of x. The degree is 3. Right, people? So we'll be writing this g of x 3 times with equal spaces. Right. Make a curly bracket here. This curly bracket should be elongated, right? It should be as large as possible because we just wanted to set this p of x using x minus 1. How we can have this? You just see the first term. First term is x cube. How we can have x cube here? When we multiply this with x square when multiplied with x, you'll be getting x cube. But x square on the other hand is also getting multiplied to minus 1. So we'll get minus x square. Here we need to have minus 6x square, right? Now this part is exhausted. Forget about this part. We should jump to this part, right? Minus 6x square is something that we need. We already have minus x square. That means minus 5x square is something that we need to add here because these are like terms. Then we'll be getting minus 6x square. Are you people with me on this? That means you need to ask it to yourself by what number or term I should be multiplying it with so as to have minus 5x square, right? So it will be minus 5x. When you multiply minus 5x with x minus 1, it will be minus 5x square. But this minus 5x will also be getting multiplied to minus 1. So it will be plus 5x. We need here 11x, right, people? So in order to have 11x, we need to have plus 6x here, right? Ultimately, we need to have this polynomial and this polynomial is one and the same, right? We are adjusting the terms, that's it. How do we have 6x here? When we multiply this particular thing with 6, we'll be getting 6x. Last term is auto-adjusted, minus 6. See, if you multiply this 6 with minus 1, you will get minus 6. And 6 with x, you'll get 6x. So this particular polynomial is actually, adjusted. We are interested in this part. Okay, so I'll be copying this. It is x squared times x minus 1 minus 5x times x minus 1 plus 6 times x minus 1. If you scan it from left to right, you can take x minus 1 as common. So here we have x square minus 5x plus 6. We know that this is a quadratic polynomial, right? We can solve it using splitting the middle term. How we can solve this? X minus 1. See, in splitting the middle term, we need to split the middle term in such a way that the product is, if you compare it with ax square plus bx plus c, the product a into c, right? It should be splitted in such a way that the summation of this bx, the summation of a and c's product will come out to be equivalent to b, right? And the integrity of b is not supposed to be disturbed. So can I say that if I'll have minus 2x and minus 3x plus 6, then if I'll multiply the numerical coefficients, that means minus 2 and minus 3, I'll be getting plus 6, right? A is 1 here. So when you do A into C, you will be having the product. Product comes out to be 6 in this case. When you multiply minus 2 and minus 3, you will be getting plus 6. But if you add minus 2x and minus 3x, you will be getting minus 5x. So integrity is not disturbed, right? Although you can, solve this with the help of factor theorem as well. But I just wanted to, give you an insight of this concept as well, right? So if you take x as common here, so it will be x minus 2. Take x as common, sorry, minus 3 as common, so it will be x minus 2. Fine. Again, you scan it from left to right, right? You will be getting x minus 3 and x minus 2. Remove this curly brackets, it will be x minus 1, x minus 2, and x minus 3. So these are the factors. When you multiply it, you will be getting p of x, right? P of x was this x cube minus 6x square plus 11x minus 6. So this is how we have factorized using factor theorem. We have one more question which was in x to the powers, right? So let us try solving that as well. However, you can directly go with the normal course. That means you can, try hit and trial method multiple times, but that will consume your time. There are multiple ways to factorize a polynomial, but that will consume more time of yours. But factor theorem will make it simpler. You can also go with long division method, but then you need to identify g of x, like we have identified by using hit and trial method. First, we have calculated one such factor, and then we, tried solving it to the fullest. All right, so let us consider the second case, x to the power 4 plus x cube minus 7x square. What I'll do is I'll be adding a blank slide here. Just a second. Because if I'll, go with the... Okay, I'll be marking this as factor theorem. Second part. Fine. Second part is x to the power 4 plus x cube minus 7x square minus x plus 6. What I'll do is I'll be taking this as p of x and then I'll be minimizing this. Right? I hope my screen is visible now. So people, if I'll substitute x as 1, right? Again, we need to go with hit and trial method. If you substitute x as 1 here, you just need to check where you are getting 0 of a polynomial. So it will be 1 to the power 4 plus 1 to the power 3 minus 7 into 1 to the power 2 minus 1 plus 6. So this will be 1 plus 1 minus 7 minus 1 plus 6. So these are like terms, minus 8, 1 plus 1, 2 plus 6, 8. So that means at P1, we are getting the value as 0. All right. So how we can write this? We are getting 0 of a polynomial at x equals 1, which implies x minus 1 is a factor of P of x, right? So P of x we need to write again, people. P of x was x to the power 4 plus x cube minus 7x square minus x plus 6. Right. So we have this as factor, and I told you that when we are given with a polynomial, you just check with the degree. Degree is 4. That means x minus 1 is to be written 4 times with some spaces in between. All right. Now we need to have curly brackets, right? It should be elongated or enlarged so that we can, be able to write p of x in a more clarified way. All right. So let us consider this. We need to have x to the power 4 here, right? So how we can have x to the power 4 when we multiply x cube with this particular thing, right? So x cube is also getting multiplied to minus 1. So we'll be having minus x cube. But here we need plus x cube. That means we need to have plus ka 2x cube here, right? Then only we can have plus x cube. So if you multiply this with 2x square, you will be having plus 2x cube. But on the other hand, you will also be having minus 2x square. We need here minus 7x square. That means we need to have here minus 5x square. So if you multiply this with minus 5x, then you will be having minus 5x square. But on the other hand, it is also getting multiplied to minus 1. That means minus 5x minus 1 will be plus 5x. We need here minus ka x, right? That means we need to have here minus 6x. So if you multiply this with minus 6, it will become minus 6x, but this minus 6 is also getting multiplied to minus 1, so it will be plus 6. I told you that last term is auto-adjusted. You need not do anything. Now we are interested in this part. Okay, so I'll consider this. It is x cube, x minus 1, plus 2x square, x minus 1, minus 5x, x minus 1, minus 6, x minus 1. If you scan it from left to right, you will be having x minus 1 is common. So it will be x cube plus 2x square minus 5x minus 6. And then we have x minus 1, right? Again, people, we need to factorize this. We have not done the factors yet, right? This is a cubic expression. We need to follow the same method here, right? So you try substituting different values, and then you can, have this, what we say, considered. So let us try this. If we put x as 1 in this, x cube, okay, I'll be considering this in a different space. If you substitute x as 1 here, 1 cube plus 2 into 1 square minus 5 into 1 minus 6. So we'll be having 1 plus 2 minus 5 minus 6. Obviously, we are not getting 0 here. Now you need to check on what parameter we are getting 0. All right. So try substituting different values. So if you substitute x as minus 1, all right, try x minus 1 here. So it will be minus 1 ka cube plus 2 into minus 1 square minus 5 minus 1 plus 6. So it will be minus 1 plus 2 plus 5, and this is minus 6 actually, right? So this will be plus 7 minus 7. Bingo, we are getting a 0. That means at x equals minus 1, we are getting 0. So one such factor of this will be x plus 1. Now, as the highest power is 3, we need to multiply. We need to have x plus 1 3 times, right? And this x minus 1 is one such factor. We are factorizing this part, right? So x plus 1, and x plus 1. Okay, we are keeping this separate. That means we need to have here x cube. So if I'll multiply this with x square, I'll be getting x cube. This x square is also getting multiplied to plus 1. So it will be x plus x square. We need to have plus 2x here. 2x square. That means we should be multiplying it with 2x square, right? No, it should not be 2x square. It should be x square only, right, people? It should be x square only, because we are already having 1x square. We need to have 2x square here. So if I'll multiply this with yet another, if I'll be adding yet another x square to it, it will be 2x square, right? But we are also having plus x here because this x is getting multiplied to plus 1. We need to have minus 5x. So that means we need to multiply this with minus 6. Then only I'll be having minus 6x here. Like terms are to be added, right? So it will be minus 5x. And when you multiply minus 6 with plus 1, you will be getting minus 6. Last term is auto-adjusted. And here we have x minus 1. All right. So this will be, okay, we need to consider only this part. X square plus x minus 6, and this will be x plus 1. And then we have yet another factor, which is x minus 1, right? Again, this is a quadratic function. We need to solve it again, right? How we can have this solved, people? Again, you need to have other factors to be considered. You can use splitting the middle term, right? Whatever means you're comfortable with. So let us consider this using splitting the middle term, and I'm rearranging the terms. X plus 1, x minus 1, and here we have x square plus x minus 6. All right. So people, if you consider this, right, a is 1. If you compare it with ax square plus bx plus c, a is 1, b is 1, and c is minus 6. We need to have a into c first. So that means 1 into minus 6, it will come out to be minus 6. That means we need to split the middle term in such a way that the product should be minus 6, but the summation should be plus 1 only. So can I say, if I'll be splitting it like this, plus 3x minus 2x will give me numerical coefficients. If I'll multiply, I'll be having what? Oh, I'm extremely sorry. It is x minus 1. Numerical coefficient, if I multiply 3 and 2, I'll be getting minus ka 6, right? Plus ka 3 and minus 2, minus 6. So this is all set, right? It is upright. X plus 1, x minus 1. If you take x as common here, so it will be x plus 3. Right? If you take minus 2 as common, again, it will be x plus 3. Fine. So from this, we have x plus 1, x minus 1. If you scan it from left to right, x plus 3 is one such factor. All right. And x minus 2 is one such factor. So that means this will be x minus 2, x minus 1, x plus 1, and x plus 3. So these are the factors. Right, people? So I hope I have answered your question, although this is a very short video, but yes, I have solved a few questions that I got in my DM. Thank you so much. And do share the same in the comment section in case if you want any other thing to be discussed. I'll be happy to, have a video on that. Fine. Do subscribe the channel as well, people, if you are new to the channel. All right. Bye-bye. Take care. Stay safe. Bye.